All right, let's take a look at this bell ringer. So as the instructions say, we're going to factor out the common expressions or pulling things out that each term has in common. Now, the word term just means a value that's added or subtracted from another. So that's what term means. And if you wouldn't mind putting away the technology, I'd really appreciate it here. So let's start with first, I'm going to differentiate. Let's pull out a common factor that's not the greatest common factor. What is a common factor between the numbers 4, 8, and 12? A number that's common, but that is not the greatest. 2. So someone could say 2 is a common factor because 2 can divide into 4x cubed. It can divide into 8x squared. It could also divide into 12x z. However, 2 is not the greatest number that can do so. What's a larger number that can go into all three terms? 4. So part of our greatest common factor would be the number 4. So when I start talking about the greatest common factor, I might say GCF, greatest common factor. That's the largest number or term that could divide into whatever group you're looking at. Now, that is not actually the correct answer. If I left it just as 4, I'm wrong because there's something else that's shared as well. The value x. So the variable x is shared. So what we would say is truthfully, the greatest common factor is 4x. And so here's how you would write or divide out with the greatest common factor. It's actually the exact opposite of distribution. If you think of distribution with having a value in front of a parenthesis that you multiply through, well, greatest common factor is the exact opposite. It's like you divide out to create the parenthesis. So if I divided 4x cubed by 4x, the 4's simplify with one another or cancel each other out. X cubed is the same thing as x times x times x. So I have x times x times x, but I'm dividing by 1x. So if you have 3 new x's multiplying here, but you're dividing out one of them, how many left over? 2. So you should have an x squared in that first location. You won't change the operator, the addition symbol there. Okay, now let's go to the second term. What is 8x squared divided by 4x? I hear 2x. I agree with 2x. And finally, over here, 12 divided by 4 is 3. X divided by x simplifies. It's just 1. And it's not 31. So don't write 31. It's technically 3 times 1, which is still 3. But then I have the z. Now, a lot of my students in years past say my z's look like 2's. So that you don't think that's a 32, I'll add a little line there. That way you know it's 3z. This is our solution to number 1. That would be the solution with the greatest common factor of 4x. All right, now let's try number 2 here. Number 2, greatest common factor. We're going to work our way to the greatest common factor. Let's begin with finding what integer value is the greatest common integer. 3. Check it. 3 goes into all of them. And what's wrong with 9? Why would 9 not be the greatest common integer factor? Because 9 cannot divide into 3. That's correct. So it will be a 3. Okay, what about the variables? They all have an x. And what about the y's? A y? Would it just be y first? I hear some people saying y squared. Which one's accurate? Y squared. They all have at least 2 powers. So we could divide out 3xy squared. And so one little comment I'm going to make on that is that even though this is a squared and this is a 3, you're not saying can 3 be divided by 2? That's not the way of thinking about this. The way you think about this is representing y times y times y. And this represents y times y. So 2 y's multiplying 3 y's multiplying. 2 of them can be canceled out. So that's what we would divide by all the way across here. So 9 divided by 3. Again, this is reverse distribution. So it should look like a distribution when we're finished. 9 divided by 3 is 3. X squared divided by x. X to the first. And y cubed divided by y squared. Okay. Now we have the operator or the addition symbol. 3 divided by 3 simplifies, or some people call it cancels out. X divided by X simplifies. Y divided by, or excuse me, Y squared divided by Y squared also cancels out. If everything cancels out, do I put a 0? No, because we know 3 divided by 3 is not 0. 3 divided by 3 would be 1. If it were 10 divided by 10, it'd be 1. Well, 3xy squared divided by 3xy squared then is going to be just 1. Okay, then we have another operator. What's 27 divided by 3? 9. X divided by X simplifies. Y fourth divided by Y squared. Y squared. There we go. This would be your solution to number 2. Now, in case we get to it at the end, I forget to tell you this because this is the beginning of school. I want to make sure you'll know where you'll end up turning in all this as we go, as we complete the lesson. This lesson at the very top of it, you'll notice on your packet, it says 1-0 factoring polynomials. Where you would turn that in is you would go to chapter 1. That's what the 1 refers to. And this would be lesson 0. This is a review lesson from algebra 2, which means you would be turning it in this box right here. And 1-0. Down near the bottom, under lesson exam, 1-0, that's where the BR stand for bell ringers. That is the bell ringer. We've done that portion. Now we'll get going on the lesson and complete the DOLs. If you can see that there, you have completed task 1 by showing up. Everybody before advisory completed task number 2, which was attendance. Now we're going to work on number 3, completing this exam. We've done the bell ringers. Now let's get going to the DOLs. Here we go. Just have another copy. Why not? All right, today what I'm going to focus on is factoring a trinomial for most of the class. I call this X method factoring. It's factoring a trinomial. What's the word tri? When you hear tri, what do you think of? 3. So I'm talking about 3 terms here. How do we factor something with 3 terms? You will see me throughout the year refer to it as ax squared plus bx plus c, where a, b, and c are all integers, meaning whole numbers. Numbers like 5, 3, 2, 7, 14, 16, any 3 numbers. So A, B, and C will be replaced by numbers. The X is the variable that remains, okay? We are going to take equations like this throughout most of the class and turn it into linear products or linear factors. You could also exchange this word with factors. Now, what does products mean?
The answer?
The answer of what? Of multiplication. Specifically, factors mean something is multiplying. Products mean something is multiply, and you're dealing with the answer. The answer is in multiplication form. Factors just means you're either multiplying or dividing. So you could use this word to summarize the multiplication aspect. So how do we do this? I do a 4-step method. So here are your steps, crystal clear for you on your packet. It says, number 1, we need to look for the greatest common factor first. This is essential to factoring. If you do not take out the greatest common factor, oftentimes we'll come up with a solution. It will not be the correct solution. So you want to go in order, and the greatest common factor is what you do first. Secondly, we'll do that X method that I'm about to explain to you. We'll split the A terms power third, and then we'll simplify with the bottoms up technique. So there's the words. What in the world do those words mean? Well, let's look at some examples so I can show you. So first step for any problem is we will look for a GCF. Okay, and so after we do that, we'll get into the X method. So what is the X method? The X method is you'll have an X, and you should have this on your notes so you can kind of fill in. So later on, you can come back and look at it. And up at the top of the X, I'm going to write out whatever the product of A times C is. Whatever my A times C is, the product of A times C will go up from the top of my square. At the bottom of the square, I will put the coefficient B. Now remember, B is going to be a number. A, B, and C are all numbers. These are supposed to be squigglies. They're not anything in particular. These are all numbers. A, B, and C are numbers. So what you should have in this X is the product of 2 values, A times C, and then here, just the number B. What we will look for are 2 different numbers, M and N, such that A times C will equal the product of M times N. So they will multiply. M and N will multiply to be A times C, and yet they will add. So they will multiply. I'll put an X there. And over here, they will add together to be the value of B. Now, I'm putting a add. It could be subtract if one of them is negative. But that's the idea. And so that's what this slide is showing you here. But again, there's no numbers here. So for some students, it's harder to grasp. But this is just a guide so that at the end of class, hopefully, if you look back, this will make perfect sense to you. So there's your guide. So now let's try some problems. So here's a trinomial. 3x squared plus 27x plus 60. What we're going to do is we are going to factor it into, here's another word, linear combination. They could have said a linear product or a linear factor. So what was step one without flipping backwards? Who can remember?
Figure out the greatest common factor.
And I'm just going to say GCF. I'm not going to say look for the GCF. I'm just going to say GCF. All right. So does this trinomial have a GCF? 3. Now I'm going to say NA if it doesn't have one, or we can write none. But this one does. What's common all the way across? 3. Okay. So if we divide out of 3, let's see what we're left with. 3x squared divided by 3 would be x squared. 27x divided by 3 would be 9x. And then finally, 60 divided by 3 is 20. Am I writing large enough for you to see? Okay. And again, there's not that many benefits to COVID, but one is that I'm now on Zoom. So if it's too small for you, just open up your laptop and open up the Zoom and mute it. And that will work great for you too, just to have one on right on their desk. So there's our GCF. Now here's what I want you to know. We're going to treat this as the trinomial. This is the trinomial now, which means A is not going to be 3. My A value is going to be technically 1. A will equal 1. B is now 9. And C is 20. Okay, step 2. I said step 2. How about just step 2? Does anybody remember what step 2 was about flipping backwards? Very good, Bella. X method. Okay, so show of hands. How many use X method with your Algebra 2 teacher? Great, 2 of you. A few more hands are going up. So that was sarcasm there. But you'll learn it here. It's very helpful. So remember that A times C is going to go on the top of the X, and the B value will go on the bottom of the X. So A times C, it means 1 times 20. What is 1 times 20? 20. So the product is 20. And then 9 is our B value. So here's what we're going to try to do. And I like to list out the options. We're going to come up with 2 numbers, which I, on the previous slide, referred to as the letters M and N, but 2 numbers that multiply to be 20 and add to be 9. Now, some students are like wizards, and all year you're going to blow away the other students. You're like, how do they know that? I don't know. The numbers just pop in my head. I don't know how I know them, but they just appear there. Other students need a technique. Here's for the students who struggle in this stuff. Here's a technique. I write out all the products of 20. So 1 times 20, and I count up. I start with the number 1 and count up. 2 times 10. 3 does not go into 20. 4 does. 5 times. Now, once these 2 numbers get to be either the same or whatever, you don't have to keep writing them out like 5 times 4. You don't have to keep going. 4 times 5 will cover it. So I'm done here. And so once you write out the factors, now you just say, okay, which one can combine to be a 9? Which pair? 4 and 5. These are our numbers. M and N is 4 and 5. Now, step 3. This one I teach a little bit different than other teachers. So I'm just going to go ahead and tell you it's split A terms power. I'm just going to write A power. I'm really referring to the A term. So we're going to split this power. I'm going to take the GCF 3. And instead of it being 1x squared, if I split this power, now you need to remember this all year. In pre-calculus, we deal with some larger powers as we go along. If you split 2, what is half of 2? 1. So it's going to be x to the 1 power. And now you throw in the first number, which is plus 4. And then you'll have another parenthesis with the other half of the power. So x to the other power, this the second power of the two powers. And this one's going to have a plus 5. Right there. Come on in. Remind me your name. Jennifer. Okay, make sure you do take your attendance. Okay. The last step is bottoms up. Now, how many Miss Lester students have I have in here? Okay, so you could probably describe better if you remember bottoms up. I don't actually remember why she calls it this, but I do know the technique. That I remember. The technique is this. You look at each factor. If there is something common that could be divided out, you do so. On this problem, is there anything shared between x and 4? No. Is there anything common between x and 5? No. So this one actually does not get simplified. So I'll just do here NA, or you might write none if that helps you remember that we didn't actually do anything. That means the answer is this right here. That is the solution. Now, what I'm going to do is prove it to you. So as you kind of finish up your notes here, I'm going to go over to Desmos. That's what I use for graphing, as you can do this at home. And I will prove to you they are the same equation. Now, how will I do that? Well, a little trick called graphing. It's a new thing, brand new thing, graphing, right? Just kidding. It's not brand new. We've been doing it for a long time. But what I'm going to do is type in our original, and I'm going to type in the solution. And I want you to tell me, what do you notice about these two graphs?
They overlap.
They overlap. So what does it mean if two graphs are identical? That these two equations are also identical. So we got the correct answer. What is the name? I want a little quiz here. What's the name for the 3 itself? That factor of 3. That was our,
Oh, just yeah.
which stood for greatest common factor. Now I'm going to ask questions all year. No worries if you get something wrong. Doesn't matter. Okay. So, and a lot of times I ask questions, and I'm a what's it called when you talk and you kind of process what you're saying as you talk. So sometimes I'm going verbal processor. Sometimes I'm going to ask a question, and as I say it, I realize that makes 0 sense. So you might respond to how I said it, and I'm going, that's not at all what I meant to say. Let me try again. Okay, so don't be afraid to answer and maybe like, oh, that's not what I meant, because you still might be right. So the answer here that I was looking for is the number 3 was our greatest common factor. What would you call these two factors? Let me go over here and show you on the board. These would be called, wow, you just can't see this. This is my first year in this room with students in the class. These would be called linear factors. Why they call x plus 4 and x plus 5 linear factors is because the equation y equals x looks like what? Y equals x looks like a line. And so the plus 4 would just shift up. Sorry. There we go. The x plus 4 would just be a line that shifted up 4 units. They would call x plus 5 a linear factor. Why? Because if you graph just the x plus 5, what's it going to look like? A line. Now, you might say, well, y equals 3 looks like a line. Well, if it's flat in mathematics, and I'm about to show you all 3, we call that a constant function, not a linear function. A linear function will have a slope. If it's a constant function, that means the slope is 0, and we don't consider that a linear. So just to put this into perspective, the 3 would be called the greatest common factor. The x plus 4 and x plus 5 would be linear factors, because here's what their pictures look like. Y equals 3 is a flat line at 3. That's called a constant function. Y equals x plus 4 is a linear function. Like I said, a function that's just been shifted up 4 units, and then y equals 5, very similar, just 1 unit higher, linear function through there. So there's the vocabulary put to images. Hopefully that helps you understand why are we calling these linear factors? Well, because that's what they would look like if you graphed each factor individually. With that, let's try another problem. Who remembers step 1? All right, I'm just going to say number 1. We'll make it easier. Number 1, greatest common factor. Do we have a GCF here? So 2 does go into 4 and negative 12. That's true. Does it go into 1? No. So I'm going to do NA. You could write none. NA stands for not available. There is none. Number 2, What was our number 2 step?
The X.
The X method, that's right. Okay, if you remember, it's going to have the factors A times C up top and the value of B down below. 1 is our A, B is our 4, and C is our -12. Now hear me say that again. When I say A, I'm not saying 1x squared. That would be the A term. A itself is only the coefficient 1. B is just that coefficient of 4. C, take this, is -12, not +12. C is -12. So in this case, what is 1 times -12? -12. Very good. And then our B value is simply 4. Okay, so now let's find these two values, M and N. And again, my shortcut is I write out the factors and I ignore the negatives. I just deal with positive factors. So I'm just going to think of through the factors of 12. We have 1 and 12, 2 and 6, 3 and 4, and I'm out. The numbers have come next to each other, so I'm out. There's not going to be any more. They're just going to duplicate over. So now I know they got to multiply to be -12 and somehow add to be 4. Which combinations could add or subtract to give me 4? Okay, I'm hearing 6 and 2, but I also heard you include a negative. So these 6 and 2 is going to be our combination that gets us 4. How do I make it a 4? 6 minus 2. Okay, so I'm going to write it out that in order over here. 6 minus 2 would be 4. 6 times -2 would be -12. We got our numbers. Step 3. Split. And again, I'm writing it out shorthand, but it would be the A terms power. If you remember, the A itself is 1. I'm not splitting 1. I'm splitting.
It is 9:30. Please stop, drop, and submit your enrollment count. Thank you.
All right, I'll do that in a second when we get to our first DOL here. I'm going to split this power, which means the first power was a squared. If you split a square, what do you get? Just 1x. Okay, so I'm going to have a 1x in each parenthesis. A 1x and a 1x. My two side numbers are 6 and 12. 6 is positive, so I'll do +6. And I have a -2. Let me get that parenthesis closer. Now that's step 3. Who remembers number 4?
The bottom's up.
Bottoms up. Now what you do is you look for basically a GCF that can divide out in each individual factor. Is there anything common between x and 6? Nope. What about x and -2? Nope. So that is our solution. I will do an NA here. And I will show you one a little bit where we do have a bottoms up. You will see that today. But I'm just kind of building on what we have so far. I think I have, need to be following my own here, one more before I actually give you a DOL. So let's knock that out. Example 3 here. In the far back corner, either Diana or Alondra. What was step 1? Yeah. There you go. Greatest common factor. All right. So Diana mentioned it. Alondra, do you know of any number that could go into 6, 8, and -8? 2. I agree with you. 2 is our greatest common factor. Can 3 go into all 3? Could 4 go into all 3? No. So 2 is the greatest common factor. Not just a common factor, it is the greatest common factor. So if I divide out that 2 or pull out that 2 like the bell ringer said in quotes, what are we left with? Well, what is 6 divided by 2?
3.
So I have 3x squared. What is 8 divided by 2? And then -8 divided by 2. -4. Very good. This becomes our new A, B, and C. A is 3, B will be 4, C will be -4. Middle table. Joshua or Jose? What's step 2?
Good morning, Skyline teachers. It is now time.
All right, Joshua, Jose. Step 2.
X method.
X method. Okay, so Jose, what numerical value will go on the top of this X? I agree. 3 times -4. What do we get, class? -12. Good. Okay. And our B value, someone else just call it out. 4. Okay. I'm going to find the two values. Again, I use the letters M and N. You can use whatever you want, but that's what I've had on my notes, so I'm just going to use. I write out the factors of positive 12. I don't worry about the negative until the last step. So I have 1 times 12, 2 times 6, 3 times 4, just like the previous problem. Now, you might remember on the previous problem, we were also trying to get to 4. How did we get to 4 last time?
6 minus 2.
All right, we said 6 minus 2. So I'll write it out in that order. The order honestly doesn't matter here, but since I have them over here, I'm going to just fix it so it's easier to see that 6 minus 2, yes, that is 4. 6 times -2 would be -12. Okay, so are we going to get the same answers last time? Answer is going to be no. I'll show you why. Step 3 stands for, yeah, split the A terms power. So which means I had a GCF of 2. I'm going to write out the 2 in front. Let me rewrite this again. Sorry, 2. And my A terms power is a squared. When I write this out, I'm going to write 3x. So I'm splitting the A terms power, not the coefficient. I'm splitting the power. So I have 3x plus 6. And I have 3x minus 2. Now, if you had Miss Lester, I don't know if she does this step exactly the same as me. Might look a little bit different, but as long as you get the right answer, I don't care how you do it. Okay, so with that being said, I split the A terms power. I did not split the coefficient. Notice I now have 3 times 3. Now tell me, up here, I'm supposed to have a coefficient of 6 as my leading term. Leading term means the highest power term. If I multiplied this 2 times 3, I would still get a 6, correct? Right now, I am incorrect. This is where bottoms up comes in. Because if I multiplied this out, the leading term would be 2 times 3x, which is 6x. But then I would multiply it times this 3x, and I would get 18x squared. Do you see the problem? 2 times 3 times another 3 does not equal 6. That actually equals 18. So I have an extra value of 3. So what happens to it? Step 4 happens to it. Step 4 is called bottoms up. Okay, if you might have noticed, on step 3, I took one value of A and I made it 2 values of A. So I have an extra value of A in there. We have to divide that out. Which parenthesis can be divided by 3? The front parenthesis or the back parenthesis? Which one can be divided by 3 evenly? The front. Whoops. The front parenthesis can. So bottoms up on this case, I will do to get our solution of 2 times, this becomes x plus 2, and the back parenthesis remains the same, 3x minus 2. We've got our solution here. That is bottoms up. Now you only got to see bottoms up one time. Any questions over that? Could anybody think of a rule of when you will always have to do bottoms up and when you will not? There is a rule. Does anybody know what it is? It's whenever your A is greater than 1. If your A is greater than 1, you'll have to do bottoms up. The previous problems, if you look back, A was 1, so we did not have to do bottoms up. A was 1, did not have to do bottoms up. That's the rule. If A is larger than 1, like it was here, you will have to do bottoms up on at least one of the parentheses. Sometimes they both get divided a little bit, but you will have to do bottoms up if your A is larger than 1. That's the rule. You don't have to know the rule, but I'm just telling you that is the rule. With that, I'm going to give you your first DOL, and then I'm also going to do that enrollment count. So here it is. I want you to factor this trinomial. You'll have a couple minutes. All right, let's continue on. So now I'm going to give you more examples so we really learn this well. Step 1. Table in the front right, Jay, Bella, or Jemiah. What was step 1? Jamia. Greatest common factor. Good. Do y'all have one, or do you see one in this problem? No, no GCF, so this is not available. So I'll continue on. That means I'm going to go ahead and label, now that I know there's not a greatest common factor, that in this problem, A will be 2, B will be -5, C will be -7. Notice that the symbols go with them. If you're wondering, why did I not say plus the numbers when they had addition earlier? Well, when you just say a number, you assume it to be positive unless you say the negative. So A is, I'm just saying 2. I could say A is +2, B is -5, C is -7. All right, with that, let's go on to the next step. Step number 2, front table. What was step number 2? X method, you got it. So for this particular problem, what numerical value would go in the top of the X? -14. And how did you get that, Jay? 2 times -7, A times C. Great. What value would go at the bottom of our X? A -5. So that comes from the value B. All right, so here we haven't done this one yet. So factors of, I'm going to write down factors of 14. I'm going to ignore the negative for a second. So I'll have 1 and 14, 2 and 7, 3 does not go into 14, 4 does not go into 14, 5 doesn't, 6 does, 7 does, but that's with 2 and it's already there. So it looks like that's my list right there. Which one could give me a -5? Yeah, I hear 2 and 7. Sydney, what combination of 2 and 7 give me -5? That's right. 2 minus 7. 2 minus 7 would be a -5. 2 minus 7 is -5. 2 times -7 is -14. Perfect. So I go on to step 3. All right, Eva, what do you think step 3 is? Split the A terms power. That's correct. You got it. Split the A terms power. So when I do that, my A term is 2x squared. So when I split that power, Alexander, what does it become when I split this power? 2x. You got it. I'll have 2 parentheses, 2 factors that will begin with 2x. Each factor will end with the side number. So it'll be 2x plus 2 and a 2x minus 7. On the Anna table, will this problem have a bottoms up step?
Yes,
Yes. Why will we?
because it's greater than 1.
That's correct. Our A value is greater than 1, which means somewhere in here we'll divide by the factor of 2. Will it be the front parenthesis like or the back parenthesis like this? The front. So when I divide that by 2, we're left with our answer. X plus 1 times 2x minus 7. By the way, it doesn't matter the order of which you write your linear factors. While you finish up writing, why do we call those linear factors again? Each one graphed individually would be a line with slope that's not constant, or not a zero slope, rather, I should say. Not a zero slope. Both y equals x plus 1 and y equals 2x plus 7. Which one would be the steeper line? Which line would be steeper? I heard someone say, you got me. So let's look at it. Which line is steeper, red or blue? Blue. The greater the value, the absolute value of the A term, the greater the steepness. The smaller the absolute value of the A term, the less steep it becomes. All right. One more, I think, and then it'll be your turn for DOL number 2. Let's go quick through this. Step 1. Call it out as a class. What's step 1? GCF. 15, 7, and -2. None? Okay. Step 2, X method. What value goes in the numerator, or it's numerator, top of the X? Negative 30. I love how specific you are. It's not 30, it's negative 30. I love that because A time 15 times a negative 2 is negative 30. That leaves us 7 for our B value. All right. Again, I know some of you are wizards and already have the numbers, but for those who are not wizards, I have 1 times 30, 2 times 15, 3 times 10. Does 4 go into 30? No, 5 does. 6 times. I won't have any more. We're looking for a combination of 7. 3 and 10. Specifically, how does 3 and 10 become a 7? 10 minus 3. Good. You could say negative 3 plus 10. I've heard that, and that's fine. But I think it makes more sense to all students in the room if I write positive followed by negative. So we move on to step 3. Split the A power. So real quick, if your conversation is about the math, I'm okay with it. If it's not, if you wouldn't mind holding that for a little bit, that'd be great until your DOL. If it's about math, it's always welcome now. Split the A power. Okay, so we're splitting the A term, 15x squared's power. So what does that mean? I need to write in the front of this parenthesis? 15x, that's right. So both factors, both factors are going to begin with 15x. We know they're not both going to end that way because A is greater than 1. So here I have a plus 10. Here I have a minus 3. Now this problem's cool. What do I mean by cool? Well, a math teacher's cool is usually different than your cool. But why do I say it's cool? What we've seen so far is that if A is greater than 1, we've divided by that value of A. It doesn't have to be that way. Really what I have is an extra factor of 15. I need to divide out an extra factor of 15 to get to the correct coefficient. But as I look, I can't divide the front parenthesis by 15. I can't divide the back parenthesis by 15 either.
I want to remind our teachers.
Okay, so let's see what happens. Let's see what Mr. Voorhees cool looks like. In the front factor, this linear factor, what could be reduced? What is common between 15x and 10? 5. Okay, so 5 could divide into the front linear factor. What about this back linear factor? What's common? 3. Now, here's how this works. What is 3 times 5? 15. So I am dividing out factors of 15. It just doesn't look like a 15. It looks like a 5 and a 3. But we mathematically get this true solution. 15 divided by 5 is 3x. 15x divided by 5, I should say, is 3x. 10 divided by 5 is 2. And then the back linear factor, 15x divided by 3 is 5x. And negative 3 divided by 3 is negative 1. There's our solution. While I give you a moment to write it, stay with me here, please. Stay with me. I'm going to prove it to you. Okay, what I'm doing here is I'm proving to you that this solution is correct. How did I just prove that our solution is correct?
They overlap each other.
They overlap one another. So we did get the correct answer. All right, which brings us to DOL number 2. I'm not going to give you as much time to solve this problem, but I'll give you a moment. All right, let's try using your own steps. DOL number 3 immediately follows. So now try this DOL, finding your own steps. All right, so to date, everything I've shown you thus far after the bell ringer has been a trinomial, or maybe even the bell ringer might have been a trinomial. I don't remember exactly, but everything I think you've seen is a trinomial. Now, at the end on this section here, it's called extra examples. I'm going to show you stuff when it's not a trinomial. What might we do? Well, if it's two terms, you could do easier techniques, or you could do the same technique. I'll show you one using the same technique just so you can have, if you're like, hey, I got a plan, I'll just do that, what I know how to do. If you want to do that, what you need to look at is which term are you missing? Are you missing the A term, the B term, or the C term? And you determine that looking at the value or the power of X. What am I missing here? A, B, or C? I'm missing B. Now, Sydney, I heard your voice is really authoritative. Why? How'd you know it was B?
Now the original problem we had, it had a single variable with no power.
It had a single variable of X without any power attached. This does not have that. So what that means is I could look at this as an A value of 2. Let me write it up here where I was. A of 2. I don't have any 0x. I have 0 x's here. So my B is a 0 and my C is a negative 32. Now, if you wrote it that way, you could solve the problem. Now, I'm going to go through a little bit faster because some of you might want to see a second method that's a little bit quicker if you're missing a B, and I'll show you that in a moment. But I'll go through normal. So here we go. GCF first. On this one, what is common between 2 and negative 32? 2. So I could factor out the 2. And so we would have 2 times x squared minus 16, which now means these values have changed. Now my A is 1, B is still 0, and C is negative 16. So I go on to step number 2, which is X method. And on X method, we would have our A times C here, which is negative 16. And now we need to include the B value. Now, what do we say B is if it's not there at all? 0. So you're looking for factors of negative 16 that add up to 0. So what would those be? Well, you haven't seen this before. That's why I call it an extra example or a trick problem. So the factors of 16, positive 16, would be 1 and 16, 2 and 8. 3 does not go into 16, but 4 does 4 times. Which two numbers could combine to somehow give us 0? 4 and 4. Now, how do I make 4 and 4 become a 0? How about 4 minus 4? And so step 3 would be the split the A power. And really, I mean the A terms power. A terms power. I'll actually write that out this time. That's what I truthfully mean. And so what that means is the 2 on the GCF remains. I split 1x squared to become 1x and another 1x. And then the two side numbers are plus 4 and minus 4. Am I going too fast? Okay. Finally, step 4, bottoms up. Well, this problem, like the very first few problems I showed you, my A is 1. So that means I don't have to worry about bottoms up. Nothing gets simplified. So that is our solution here. Okay, so that was using the 4 terms. Someone might say, well, you said there was a shorter way. Yes, if you're missing your B term, you can always do what's called square root technique. So how does square root technique work? Well, first, this is now, let me write it out. Square root technique. If you ever hear that or see me or hear me say that or see it written somewhere, here's what square root technique means is first you still do a GCF. And so we would have 2 times x squared minus 16. And then you do the square root technique is technically difference of squares. That is an ugly F right there. I'm sorry. Difference of squares is the proper name. What you do is you would take that parenthesis and you take the square root of each term. What's the square root of x squared? Try again. Square root of x squared is x. So we'd go x and x. And what's the square root of 16? 4 and 4. Difference of squares, what you learned in algebra 2 is difference of square means you make one positive and one negative. Notice we have the same answer. And so again, the pattern for difference of squares is when you're missing a b value. So I'm going to go now back and now add that note so you have it. When can you use the square root technique? It's when you're missing the b term. Let me put it in quotes because I've been putting the a term in quotes all day. Let me stay consistent. If you're missing your b term, you can do the square root technique where you do GCF and then take the square root of each, make one positive, one negative, and you got it, call it a day. A nice little shortcut there. So that would be called a binomial, by the way. This is a binomial. Bi means 2, and there was only 2 terms. All right. So I got 3, if I remember right, 3 trick questions to show you. So there was 1 binomial. Now I'm looking, there's 4. Stand corrected, there's 4. There's 1. Okay, let's go to number 2. I shouldn't say number 2, number 7, second trick question, but number 7 here. All right, what are we working with this time? Trinomial. So this would be straight up X method territory. But what's a little different is under step 1, the GCF is a little bit different than what we've been working with. What's common all the way through here? X does go all the way in, as well as the number 3 goes into all of them. And here's the other thing. I don't like working with a negative a because it tricks you up later on. So I always, if a is negative, I always GCF it out. Now a question might come up, what if these numbers did not go into one another? Like that's a 7. Well, then I would take out a negative 1. But in this case, they do. So I'm going to take out a negative 3x. So that's what I'm going to factor out, negative 3x. That leaves me with, let's see, negative 6x cubed divided by negative 3x would be 2x squared if I'm doing my math right. Now I have a negative 3x trying to divide into a 63x squared. I'm going to get a negative, very good math, 21x. And now finally, negative 30x divided by negative 3x is a positive 10, no x, just a positive 10. Which means we now made a positive value, it's positive 2. B is negative 21, C is 10. Step 2. What is step 2? X method. So here we go. Factors of A times C. 2 times 10 is 20. B is negative 21. We're going to look for 2 numbers. I'm going to use the variables m and n. They're going to multiply to be 20, add to be negative 21. So here are your options. 1 and 20, 2 and 10, 3 does not go into 20, 4 does, 5 times we're out because the numbers are, you can stop anytime the numbers become the same or 1 apart. Which of these combos could somehow give me a negative 21? Yeah, the top. Now, how does 1 and 20 become a negative 21? Both negative. Very good. Negative 1 minus 20 more is negative 21. Step 3. What do we call step 3? Yep. Split A's terms power. So my A term was 2x squared. Don't forget the GCF here. So 2x squared being split becomes 2x and 2x. My 2x value or the m and n values go into parentheses, -1 and -20. Step 4. Will I have a bottoms up step this time? Oops, I forgot to write the 4. Number 4. Bottoms up. Will we have to do bottoms up or can we skip it on this problem? We have to do it because A is greater than 1. Okay, so in the first 2x minus 1, anything common? What about this second factor? 2x minus 20. 2. And that makes sense because A was 2, but I wrote it twice. So that'll get rid of the second coefficient of 2. So now that means this problem is different. We have 3 linear factors. I have negative 3x, I have 2x minus 1, and I have x minus 10. Bonus points for who can remember from earlier. Which of these 3 linear factors has the steepest slope?
The x, the 2 squared, I mean 2x.
It's actually the negative 3x because you look at the absolute value when you talk steepness, it doesn't matter if it's steep going up as you move right or going down bottom right. The negative 3 would be the steepest slope. Which one would be the least steep? X minus 10 factor. That would be the least steep. That means this one is obviously in the middle. 3 linear factors make up this problem. Right, let's try 8. What could be tricky on 8? What are we working with here? Trinomial, binomial, quadrinomial?
Quadrinomial.
This is a trinomial, 3 terms, 1, 2, 3, trinomial. So this is the routine 4 steps for trinomials. Step 1. What's step 1? GCF, you got it. GCF. 4x to the 4th, negative 37x squared, 9. Anything in common between 4, negative 37, and 9? None. So I'm thinking, Mr. Voorhees, nothing seems tricky so far. It says trick problems. What's the trick? Okay, this time we do X method. The trinomial A is 4, B is negative 37, C is 9. I heard the question of B. B is supposed to be x to the 1st. Well, we're going to see not this time. So 4 times 9 is 36. B is negative 37. All right, factors of 36 are 1 and 36. 2 times
18.
18, 3 times 12, 4 times 9, 5 times nothing, 6 times 6. Okay, we can stop. How can I get a combo of negative 37? Okay, how does 1 and 36 become a negative 37? And we can check it. Does a negative times a negative give me a positive? Yeah, that's it. Negative 1, negative 36. Step 3. Now be very specific. What does step 3 say?
Split A terms power.
Okay, now you haven't seen this yet. This is where the trick comes in. We're splitting the power of 4. If you're going to split the power of 4, what is half of 4? 2. So this actually becomes 4x squared minus 1. And the second factor becomes 4x squared minus 36. You got it. All right, step number 4. Does the front parenthesis have anything in common? What about the back parenthesis? Or can be divided into both. So we're left with 4x squared minus 1 and x squared minus 9. If I box this up, I would have followed all the steps from earlier, but would I have linear factors?
Oh, you still have the x.
Yeah, I still got the square.
What would we call it if they're squared? They're not linear. What do you call something squared? Starts with a Q, rhymes with quadratics.
Quadratic.
Quadratics. We have quadratic factors. So this actually is not the same. What I would encourage you to do is to write down these are quadratic factors. And so if you wanted to get it to linear factors, you'd have to factor these again. Luckily, I've already shown you a shortcut. Which value are you missing in the front factor? A, B, or C? B. What was the shortcut if you're missing a B?
Square root technique.
Square root technique. All right, let's factor the front parenthesis. or the front factor, I should say. What is the square root of 4x squared? 2x and 2x. What's the square root of 1? 1. You make one positive, you make one negative. There's the front factor. That is 4x squared. Let me make this easier. And on your pen, if you take your pencil and right click on your paper and then hit copy and then right click, hit paste, it'll do the same thing I just did on my board. Just kidding. Bad joke. Okay, so there's the front factor here. The front quadratic factor becomes linear right there. Okay, what about at the back end? We're missing a b again, so I can do the square root. What's the square root of x squared? X. What's the square root of 9? 3. So I have a +3 and a -3. There is our solution, and as a linear set of factors. How about that one, huh? And last one I'm going to show you. Before I move on to, I don't want to move too fast. I'm sure someone's got a question on this. What was the name of that? What did I call that earlier? Square root technique. If you wanted to give yourself a note, we should say, see example. What example did we do this on earlier? 6. See example 6. If you want to know what we just did there. And I will make the note, these are now what we would call linear factors. Let me write that as well, just to have better notes. There you go, that's a linear factor. Okay, I have one more to show you, and then we'll wrap it up. What's different this time? 4 terms. 4-term factoring. 4-term factoring, I'll write it out. 4-term factoring. I use a technique called grouping. Now, you won't see very much of this throughout the year. That's why I'm only doing one of these. You will see it a few times. And so I do want to show you a technique for it. But you won't see this routinely throughout the year like X method. That's why I did so many X methods. But I'm only going to do one 4-term factoring grouping technique. So here's how grouping works. You group the first 2 terms and the last 2. So let me write that down. Step 1. Group first. Let me write first 2 terms and second 2 terms. Number 2, GCF each group. Okay, on these the 2 groupings, what's the GCF on the front grouping? 4. 4 is a common factor, not the greatest common factor. 4x squared, very good. 4x squared gets factored out, which leaves us with 2x plus 1. Good, gotta add the placeholder of 1. 4x squared divided by 4x squared is 1. Just like 10 divided by 10 is 1, 5 divided by 5 is 1, 4x squared divided by 4x squared is 1. So you have to have that 1 there. The symbol in between these 2 will always fall straight down. So drop that down. What is common between this -18x and -9? -9. So I already had the minus there. So -9 or -9. And that leaves us with not 4x, 2x. What's a -9 divided by -9? Plus 1. Okay. Step 3. This is the checks. I want to say check in capitals. What do we need to check? Do the parentheses match? That's how you spell it. Parenthesis. I think this is still an A. Maybe it's an E. I don't know.
Like Aaron.
Do the parentheses match? Do they match here? Yes. If so, the factors become, one factor is what's outside the parentheses. And I'll explain why just after I write it. So 4x squared minus 9 becomes one factor. The other factor is what's inside. That's matching. Now, why is this the case? Because what we're saying is a 4x squared is multiplying 2 times a 2x plus 1, and a negative 9 is multiplying times a 2x plus 1. Since they are both multiplying times the same thing, you could write it this way and say both these two terms will multiply times this factor, because parenthesis means multiply. So that's what's happening. Since they're both multiplying times the same factor, you could just combine them as a factor. That are your 3 steps. I would say done, but are these linear factors? Is the first a linear factor? That's quadratic. Is the second a linear factor? Yes. So the second factor is good. First factor is not. We're missing a term. Are we missing the A, B, or C here? B. So let's do, what do you miss when you're missing a B? What can we do? Square root technique. And this is good, so you can see this now a third time. If you're missing a B, do the square root technique. What is the square root of 4x squared? 2x. What's the square root of 9? 3. So you'll do 1 positive and then do 1 negative. And then don't forget the third that we're leaving unchanged. That right there is our solution. All right, you have 8 minutes to complete these next 3 here.
View. This has to do with rational functions. Remember, a function that's like a fraction. It says, what discontinuities did Polly find upon her investigation of this function? Now, there's a lot of things we learned we can do with this. Discontinuities has to do where x does not exist. You get those from the denominator. What we need to look at is if we can cancel any values here, because that will create a discontinuity. So I need a factor on the top, or excuse me, the top is factor. The bottom, though, is not. So we can do the x method, which is a times c in the top and b in the bottom. My a is 1 here, so 1 times -6 is -6, and then my b is also 1, so I put 1 here. I'm looking for factors of -6 that add to 1. In this case, I believe they are 3 and -2. 3 times -2 is -6, but 3 minus 2 is 1. So I can factor the top by putting, you take this term and divide it in half, which means I'd have x plus 3 times x minus 2. And I would still have the plus 4 on the outside. So this is just another way of rewriting the equation. Now what we can do once we write it this way is we can see that these factors cancel out. Now a canceled out factor is a removable discontinuity. So when x, that value, I know it says x plus 3, but if you said equal to 0, you'd find that x equals -3 is a removable discontinuity, also known as a whole. And then the value that's left over here, when x equals 2, that's an infinite discontinuity, because you're not allowed to divide by 0. If x is 2, we're dividing by 0 here. So that is an infinite discontinuity, which will provide a vertical asymptote. Which is an asymptote, a vertical asymptote. And so I'll show you the picture in the graph so you can see what it looks like. If we went over from the start here, and I'll type in the equation just as it gave it to me originally, I would have the x plus 3 on the top over x squared plus x minus 6, and then I have the plus 4 over here. Over here at 2, we see that we do in fact have that vertical asymptote I was talking about. That occurs right there, it divides it. I'll just show it to you. We said it was x equals 2, so if I type in x equals 2 here, and I drag this over to the x-axis, it'll provide a dotted line, you can see that it does divide it. That's that infinite asymptote. And then we also have a hole at x equals -3. There should be a hole right there. Now, it doesn't show it here, but if we go to table, we can see. Press Control T, and look right here at 2, the infinite discontinuity is, any discontinuity will say undefined in our table. So we have that one at 2, and we also have it at -3. So it is, in fact, a hole right here at x equals -3. There's a hole right there in the graph. Should be an open circle like that. And furthermore, if we need to write the domain, I just want to remind you of this. You would never include something that's undefined. So you would go from -infinity all the way up to that -3. And then from -3, we would go to +2. And from +2, we'd go to infinity. The parentheses, however, says do not include those values because they're undefined. So that's what types of discontinuity we had. And we also, one other thing that the problem did not ask for but could be asked on the test is for a horizontal asymptote. And we could look here and test. It looks like it's at y equals 1, 2, 3, 4. If you're not for sure, let me take away the table. Sorry about that. Let me get that away from there. If I take away the table, I'll show you how we could, in fact, find the horizontal asymptote. It's the same way. We would just type in, you go to Menu, Actions, Text, and we could just type in, we think it's at y equals 4. Let's check it. If I type that in and then go to the graph, yep, it does in fact divide it right there. So that would be my horizontal asymptote if I need to find that is y equals 4. And now we'll look at number 18 from the Fall ACP review. It says, what is the domain of this function? Now, we've learned a few ways of doing this. One is by graphing, but I'm going to first use just the algebra rules because it's the most consistent. What you do when you have a rational, that means like a fraction, is first we try to factor and see if we can cancel anything. I see that there is a GCF here of x. They both share an x. So if I pull out an x there, it's like reverse distribution. I'm left with x plus 3. When you do this, we can see that these x's cancel, and that means we have a hole or removable discontinuity at that spot. Now, since x is by itself, it would be at x equals 0 that we have that hole or removable discontinuity. I forgot to put hole there. And then here, this is an infinite discontinuity. Which means it's an asymptote when x equals -3. So if we had to write the domain, we would write domain from the left, because this would be all reals except for these two values. So we'd go from -infinity all the way, this value comes first to -3. And since it's an asymptote, it'll be a parenthesis. And then we pick back up on the other side of -3, and we'll go all the way to 0. And since it's a whole, again, we're not equal to that value. And then from 0 to +infinity. This should be my answer right here. And then we could also graph it in the calculator just to make sure. So if I go over to graph, and I would type in the equation here, and I get a fraction, x over, I'll type in the original, x squared plus 3x. And there's the asymptote at -3 I was referring to. Now there needs to be a hole right here. The way to check is if you press Control T, at 0, are we undefined? We are. It says undefined both at -3 and at 0. So we're in good shape there. That is, in fact, a hole right there.